Okay, in this problem I've got a beam over here, a wooden beam. It has an allowable shear stress of 200 psi, and I want to figure out what the maximum shear force it can handle would be. So again, we're going to use the equation VQ over IT. So the first thing I'm going to do is find I, which is pretty simple for a rectangle. It's just 1/12 BH cubed. So I get I, again that's about the neutral axis for this beam. Okay. Then the next thing I need to do is find Q. So first I'm going to find it for an arbitrary location, and that's what we've done here. So the shear stress at some arbitrary location Y, again, is given as the centroid of this times the area of this. And the centroid is given as 1/2 Y plus 6. Okay, that's the location of the centroid of this area right here. Okay, and then the area is 6 minus y times the width, which is 8 inches as given here. So again, 1/2 y plus 6, that's the location of the centroid of this area above the arbitrary point that I'm looking at, y, times the area, which is 6 minus y times 8, which is the area of that y. Now, of course, the maximum occurs at the midpoint, so when y equals 0, I can plug that in, get 144 cubic inches. I could have probably done that directly, where the area is 6 by 8, and the location is going to be 3, and figure it out that way. But you know, either way that you do it is fine with me. So once I have I and Q, then I can apply my VQ over IT, where again T is given as 200 psi, V is what I'm looking for. Q we just found to be 144, I is 1152, and then T is the thickness across this, which is 8 inches. Therefore, the maximum load it can withstand is 12.8 kips, or 12,800 pounds. Okay, so again, using this equation, again, the newest thing, everything else, we can find I pretty directly, T is pretty easy. Again, Q is just the location at which the stress is occurring, which for the maximum occurs at the neutral axis. It's the area and the centroid of the area above, you know, where I'm cutting it, or below for that matter. So that's how you apply that shear formula.